So you guys were successful? Do you feel like you understand this? No?
So-so.
So-so? Well, what if I just at least set it up the way we had set up this problem, so you have, you at least have the starting place for how to set this one up.
The letters and
Lots of subscripts. If you don't have the subscripts, then you're sunk. Yeah. So with this problem, you think about first the logic behind it. You think about what's giving up heat and what's gaining heat. So who's losing heat? Which object loses heat? The cola. Okay. I just called it water since everything that we use is for the water, so I just called it water. And so then what's gaining heat? The ice. So the water is going from 25 degrees Celsius down to 0 degrees Celsius. So there's no phase change. So the only thing we need to do for its heat is MC delta T. And so I'll put water subscripts on all these. And now ice, it does two things. First, it warms up to 0, and once it's at 0, then all of it melts. So warming up to 0 is MC, or M ice, C ice, delta T ice. And then melting is the latent heat of fusion term, so the mass of the ice times the latent heat of fusion. So that's what we need on either side of the equation. M ice is what we're solving for. And then just to make sure that we've got the terms in our parentheses correct, since we aren't solving for one of the temperatures, we don't have to make these Kelvin, because the change in temperature from 25 degrees Celsius to 0 Celsius is a delta T of 25 degrees. It's also a delta K, or delta T of 25 Kelvin. So I don't need to convert this to Celsius to know that the delta T is still 25 Kelvin. Yeah, Chris?
But for the dimensional analysis, isn't it helpful to have those things cancel out when you're looking at units?
Yeah, I just called it 25 Kelvin.
Oh.
So dimensionally, I made sure that it had the right units. But yeah, but you could make yourself a little note in here and that said delta T water is T final minus T initial water, which is 0 degrees Celsius minus 25 degrees Celsius, which is 25 degrees Celsius, which equals 25 Kelvin. And then that will just remind you that that's how you magically went from Celsius to Kelvin. And then delta T ice, that is why I got a wrong answer the first time. T initial ice. So what I did was I forgot my minus sign on the ice. So I've got 0 degrees Celsius is my final temperature minus a negative 20 degrees Celsius. Gives me a positive change of 20 degrees Celsius or 20 Kelvin. So because I plugged in a negative 20K, then I ended up with the wrong answer, but it looked completely reasonable. So be very careful with your signs on these. All right, any other questions about this problem?
Are we supposed to get a negative in the end? You think an absolute value?
Nope, you shouldn't get a negative mass. That would violate the universe. Break physics. So you must have had an algebra error somewhere along the way. Well, I think that's really just going to get us to 1:30. So we'll have to take a pause on the lecture and go do our 3D printing tour, and then we'll come back and finish the lecture. So.